Hi everyone. Today we will be completing our notes on adding and subtracting polynomials. I want to start off with just some important vocabulary. Number one, we're going to use the polynomial f of x is equal to 9x cubed plus 10x to the fourth minus 8x squared plus 7x plus 6. And we're going to use this polynomial to complete each statement. Notice that I'm putting this in function notation. This reads f of x. This does not mean f times x. This is saying f is a function of x, where x is the input of the function and f of x is the output of the function. Okay? How many terms does this polynomial have? This polynomial has 5 terms. The degree of this polynomial, if you remember from the last notes, the degree is the greatest exponent in this polynomial. The degree here is 4. Writing a polynomial in standard form. Standard form for a polynomial are when the terms are written in the degree order from greatest to least. Sometimes I like to say descending power order. We look at the powers of each of the terms and we write them in descending order. So is f of x, is this polynomial in standard form? No, it's not. Standard form for this polynomial, I like to start with the greatest power, which is x to the fourth. So I'll start with that term. We have a positive 10x. Oh, let me write f of x first. F of x is equal to positive 10x to the fourth. And then I look at my x cubes. We have a positive 9x cubed, so we have plus 9x cubed. Now my x squareds, we have a negative 8x squared, so we minus 8x squared. Now our x's, we have a positive 7x, so plus 7x. And finally, our constant term, which is the number without an x, plus 6. Now this is in standard form, descending power order. We have powers of 4, 3, 2, 1, and 0. So see how these exponents decrease from left to right. The leading coefficient of a polynomial is the coefficient on the term with the greatest exponent. Now this is especially nice when we write our polynomials in standard form, because then the leading coefficient is just the coefficient of the first term. Right? If the first term has the greatest exponent, well, that's easy. It's just the coefficient then of the first term. So in f of x, in our example, the leading coefficient is the number in front of the first term, simply 10. So now let's talk about adding and subtracting polynomials. Adding and subtracting polynomials is just like combining like terms. It's something we all know how to do and know and love and do all the time in algebra, right? Combine like terms. Now, just a reminder that like terms are terms that have the same base and the same exponent. So examples of like terms, x and 3x, 7y squared and negative 3y squared. Notice that the base is the same for both of those. So in that last example, the base is y, exponent is 2. They're exactly the same, so we can combine those. For subtraction, I personally find it helpful to distribute the negative first and then just simply add or combine like terms. So let's take a look at some examples. Number 1, a squared plus 8a plus 3 plus the polynomial negative 4a squared plus 2a minus 10. This is just like combining like terms. I'm going to write all of my answers in standard form, so I'm going to write them in decreasing power order. We'll start with the a squareds. I see an a squared and a negative 4a squared. When I add those together, I get negative 3a squared. Notice that the variable and the exponent does not change, only the number in front. Now we look at our a's. So we have 8a here and 2a here. That gives us 10a. And now our constants, a positive 3 and a negative 10, gives us negative 7. This is fully simplified and in standard form, so that's our answer. Let's try number 2. Number 2, we have a binomial minus a binomial, so we're subtracting now. So remember our tip, distribute the negative first and then add. So distributing the negative is going to flip all of the signs of the terms in the second binomial. So 3k squared becomes negative 3k squared, and negative 1 becomes positive 1. Now that we've distributed the negative, we can just simply add. So I'm going to bring down that first binomial, and now we're just adding or combining like terms. For our k-squareds, we have positive 5 and negative 3 gives us 2k squared. And negative 2k, there's nothing to combine with it there. So we'll just bring that down. And finally, our constant, positive 1, there's nothing to combine with that there either. So our answer, 2k squared minus 2k plus 1. All right, go ahead and flip the page. We'll try number 3. 5m cubed plus 2m squared minus 10m plus 24 plus the polynomial 4m cubed minus m squared minus 20. All right, so we'll start with our m cubes. I see we have 5m cubed here and 4m cubed here. Adding those together, we get 9m cubed. Next is our m squareds. We've got 2m squared here and a negative m squared here. Gives us a 1m squared, or just m squared. And that's positive. Next up, we have a negative 10m, and that's our only m term, so that just gets brought down. And finally, our constant term, positive 24 and negative 20, gives us positive 4. And so this is our final answer in standard form. Okay. Number 4, now we're subtracting. This is the same polynomials, but now we're subtracting. Step 1 is to distribute the negative into each of the terms of the second polynomial. So our 4m cubed becomes negative 4m cubed, negative m squared becomes positive m squared, and negative 20 becomes positive 20. I'll go ahead and bring down my first polynomial, 5m cubed plus 2m squared minus 10m plus 24. And now we're going to add these two polynomials, so combine like terms. 5m cubed and negative 4m cubed becomes positive 1, or just m cubed. Our 2m squared and our m squared become 3m squared. Again, our negative 10m, there's nothing to combine with it there, so it stays negative 10m. And finally, our constants, 24 and 20, gives us a positive 44. So of course, notice the different answer when we subtract. All right. Next up, we have problem sets A and B. Now, on your own, I'm going to ask you to pause this in just a moment and try these on your own. But try the left-hand side, so like numbers 1 and 3 in problem set A and B. Okay? You can unpause and check your answers, and if you find that you got them right, fantastic. You can move on. But if you find that you got something incorrect, go ahead and correct it, and then try problems 2 and 4 on your own. Okay? So at this time, go ahead and pause the video and try problem sets A and B, questions 1 through 3, and unpause when you're ready to check your video. All right, go ahead and check your work. Again, if you got questions 1 or 3 incorrect, then go ahead and try 2 and 4 on your own. Here's problem set A. And here's problem set B. Did you get them all right? All right, go ahead and flip the page. Now let's take a look at practice C. So this one's a little bit challenging, but let's go through it together. So here, we're adding these two polynomials. Now I notice that each of these terms, many of them have 2 variables. But remember, the base, as long as it has the same base and the same exponent, we can combine those like terms. Let's start with this first one here. 10a squared b squared. Are there any other a squared b squared terms in any of these polynomials? Yes, I see one right here. The coefficient for this is 1, so all in all we have 11 a squared b squared. Next up we have a squared b, so I see another a squared b over here. We have 7 and negative 6 gives us positive 1, so plus a squared b. Next, we have a negative 8ab squared. Do we have any other ab squareds? No, we do not. So that just gets brought down, 8ab squared. Next, we have 9b, and I see another b term over here. So 9 and negative 2 gives us positive 7b. And finally, that 4a has nothing to combine with, so it just gets tacked on at the end. None of these terms in our polynomial are like terms, so we are done. And again, standard form is that decreasing power order. All right, Number 2, let's go ahead and rewrite this in standard form. Again, decreasing power order. We start with the x squared. I notice we have a negative x squared. Keep that coefficient negative 1. Okay, next is our x term, negative 3x. And finally, our constant term, which is positive 5. The leading coefficient in standard form is just the number in front of the first term. So the number in front of x squared is negative 1. This polynomial is specifically a trinomial. We have 3 terms here. Negative x squared, negative 3x, and positive 5. Okay, number 4. Let's put this in standard form. So we'll start with the highest power. We have x to the 5th. So that term is negative x to the 5th. Now x to the 4ths, we don't have any. X to the 3rds, we have 4x cubed, so plus 4x cubed. X squareds, we have 8x squared. X's, we have 2x. And constants, we have 7. The degree of this polynomial is 5. That's our greatest exponent. All right. Now let's take a look at number 5. The perimeter of any polygon is just the sum of all of the side lengths of that polygon. In general, the perimeter of any figure is just the total distance around that figure. We can find the perimeter by adding up all of the side lengths. Let's write an expression that represents the perimeter of each of these shapes. So 5a, we've got a triangle. To find the perimeter, I'm going to add up all of the sides. So the side lengths, 2x plus 1, 3x, and 4x minus 3. We're going to add all of these up. Adding is just like combining like terms. So 2x, 3x, and 4x gives us 9x. And then our constants, 1 and negative 3, gives us negative 2. And so an expression that represents the perimeter of this triangle is 9x minus 2. And last but not least, our rectangle here. So again, we can add up all of the sides. So 3x squared minus x plus 2 plus 5x minus 1 plus 3x squared minus x plus 2 plus 5x minus 1. Combining like terms, I see we have two 3x squared terms. So we have 6x squared. Our x terms, we have a negative x, a 5x, a negative x, and a 5x. That gives us a positive 8x. And our constant term, we have a 2, a negative 1, a 2, and a negative 1. That gives us a total of positive 2. Another approach that you could have solved this is we know that the perimeter of a rectangle is 2 times the length plus 2 times the width. So this you could have also written as 2 times the quantity, 3x squared, minus x, plus 2, and then plus 2 times the quantity, 5x minus 1. You do need the parentheses in order for this to be correct. All right? If you were to multiply this out, which is our next lesson, then you would find that you get the same expression as the perimeter. All right? So that wraps it up for today's notes. Thank you for joining me. This was adding and subtracting polynomials. We'll get a whole lot of practice on this in class. We'll see you tomorrow. Have a great day, everyone. Goodbye.